Okay. Usually gives, does it say to you all this meeting is being recorded?
Yeah, it did.
Yes, great. Okay, good. So this meeting is being recorded, um, and it'll be posted afterwards. So the first thing I want to talk about is just how we're going to use Zoom for doing this together. So as you may have noticed, as soon as I screen shared, Zoom put you into full screen by default. And um, I, I generally don't like that. Um, and this is something you can disable if you go into your Zoom settings so that you can decide when to go into full screen or not. And there, I looked into a whole bunch of different ways of setting up Zoom while you're in full screen. Um, but I just thought, you know what, I'm gonna just leave space on the side because honestly, I need space on the side too to have my chat open and my participants tab open. I don't have multiple monitors. If you have multiple monitors, you can put them off on other monitors, but I'm just working off a single monitor, and I imagine many of you are too. So I have these text files on the side with some instructions for what I think might be a nice setup for you. So I just want to take a minute if people wanted to do that. So the first thing, you have your kind of video panel, and at the very top of it, there's a black bar with some options. There's kind of a grid, two rectangles, a medium rectangle, and a tiny rectangle. So if you click on the medium rectangle, that should show just me, which is probably all you need because I think everyone else will have your camera off. And then from there, if you grab the lower left of it, you can actually expand it to whatever size works for you. Um, and so I think making it a little bigger could be useful if you want to see me more. Not that I'm vain or anything, but I think it helps the learning experience when you can see the person who's talking. Then through Zoom, you can also open your participants tab in your chat. The chat is more important. I'm going to have both open. I have space on my relatively larger monitor, and also it's more important for me to see it than for you to see it. But um, try to set that up in a configuration that works for you, with at the very least the video and the chat open on the right. And then in the participants box, there should be a little yes button that you can click. So click your yes button when you have gotten your setup, so that I know that you have something reasonable. And I'm assuming you can see these text files. The whole thing is a little trippy because, um, but yeah, you should be putting stuff on top of the text files. And if you have questions, just throw them in the chat. Questions about setting it up. Okay, I see a few yeses and I guess a bunch of people still setting up, so I'll wait another minute. Oh, yeah. Also, you feel free to raise your hand as well if you have a question. So there's also a raised hand option in the participants tab. And just generally speaking, if you want to ask a question, you can post in the chat or you can raise your hand. Both are fine with me. And I'll have the participants tab open all the time, so I'll be able to see raised hands. Where's the password for the Zoom meeting posted? So the password is not posted, it's embedded into the URL. So it's like Zoom slash something slash PWD equals something, and that contains the password. If you're joining from Canvas, which most of you are, you should be able to just click join. If you're on the wait list and I send it to you separately, then that URL I sent you has the password in it. And given that you're here, I guess you must have gotten in. What should I put to the participants window? So if you have space to keep the participants window open the whole time, you can go ahead and do that. But for now, there should be a yes button, and you can click the yes button, and then I'll be able to see that you're confirming that your Zoom is set up properly. So try to put the things where I'm suggesting. I mean, you don't have to, but I've left you that space intentionally so that you can have the video and the chat and see my notes all at the same time. How to only show one person. Okay, so if you go to the video, if you hover your mouse over the video part, there's a bunch of little boxes at the top that you can click on, and you can hover over them. So the one on the right is show grid video, the next one is show thumbnail video, and the next one is show active speaker video, and that's the one I recommend. If you click on show active speaker video, then it's only going to be showing the person who's speaking, which is going to be me. And then you won't have a whole bunch of videos which are possibly blocking your chat. So I'll just wait another minute. Again, please press the yes button if you're all good to go. And would I be at a disadvantage if I use Zoom in my browser? I don't know. You might just have a bit less space. I'm not really sure, but whatever works for you is fine. So I'm seeing a lot of people haven't hit the yes button yet. Are you still setting up? Are you not sure how to press the yes button? Where is the yes button? So it's in the participants box. So in your Zoom bar, which I think is at the bottom for you, even though it's at the top for me, you have a bunch of options like mute, video, and one of the options should be participants. And if you click on participants, then you should have a bunch of buttons inside the participants box, such as the yes button. And that's also where the, oh great, now I'm seeing a lot more people doing it, thank you. And that's also where the raised hand is, in case you want to ask your question by raising a hand rather than typing in the chat. Can't see a yes button. Do you have the participants window open? Oh, you're just saying yes, that you're ready to go. You've got your Zoom set up. It's just a way for me to know you successfully opened the participants box. So to Tianyi, you'll need to open the participants box. And then there should be a bunch of buttons in there. Yes, no. Yeah, awesome. So yeah, from this participants box, I might sometimes ask you to press yes or no. And that's also a place you can raise your hand if you have a question, and I'll see that. And then there's also the chat where you can chat or ask questions, that kind of thing. Okay, looks like almost everyone is a yes. So for anyone else who still has questions, feel free to post on Piazza afterwards, and we can get you sorted out. But I'm assuming now most of you have the video in the upper right. Again, you can enlarge the video by dragging the lower left, have the chat open, and if you have space and if you want, have the participants tab open, but it's more important for me to have it open so I can see the raised hand. So I'm going to press clear all now, and all your yeses are going to disappear. And then I'm going to get started. And as you'll see, I like to adjust these times so that I learn from experience. Okay, let's get started then. So, about this course, the most important link is this one here that I'll also post in the chat. And that's basically the course website, and it's on a public, it's public because last year it was private, and then a bunch of people wanted to see the course even though they weren't officially enrolled, so I just put it on public GitHub. So it looks like this. There's a bunch of links that are important for you to see, and then there's the schedule, which is the most convenient way for you to access lecture notes, like here's today, September 10th. You can click on the title of the lecture and it'll bring you to the notes, and I'll talk more about this format in a minute. And then there's some stuff about homework and all kinds of things. So that's the most important link. I have a syllabus quiz on Canvas. So basically, it's just because I want to make sure you've actually read all the stuff on here, all these documents. And so there's a quiz on Canvas that is due on Friday, tomorrow night. So if you're on the wait list, you won't be able to do that, and that's fine. So just don't worry about it. But take a look at the syllabus quiz. Do that by tomorrow evening just to confirm you've read through things. And I forgot to ask one. So again, with the participants tab, using your yes and no, it's just hard for me to know because some of you will be using smaller monitors than me. How's the font size? So if the font size is fine and you can see the text clearly, press yes. And if it's too small and you'd like me to zoom in more, press no. And I'll zoom in more if there's enough no's. I just want to make sure people with smaller monitors can see well. Okay, I'm seeing mostly yes and one no. So let me just zoom in one more level. I think this will work. There's another way for you to zoom in. What do you mean? Just responding to the chat. You put in. Oh, I see. You're saying viewers can also zoom in.
The viewers, they can put
okay. Let me try it like this for now, and please give me feedback, and we'll figure things out over time. Okay, thanks. Okay, so the next thing I want to talk about is just a really common question people are going to ask is, how does this course relate to the other machine learning course 340? And in fact, we now have a 440 that was just launched this year that I haven't mentioned. But let me just quickly say, there's a whole thing here that you can read about 330 versus 340. I surveyed this, so this is the second offering of this course. The first offering was last spring. I surveyed the students who had already taken 340, and you can look into this. Basically, people are saying, some are saying very useful, some are saying somewhat useful. Not a lot of people said it was a waste of time, so I was happy about that. So you can look through this at some point on the course website, but the kind of short version of it is that 340 has a lot more prereqs. It has algorithms, all kinds of math. And it goes into a lot deeper into the topics, into the math, into the optimization stuff. But it has more of a narrow scope in that it's really just about the modeling part of machine learning. How do you train a model? And 330 goes less deep, but more breadth. So we're going to talk about how to deal with messy data, how to deal with different types of data that aren't covered in 340. And so this course, the target audience is like, I think I'm going to be a user of machine learning at some point in the future, and I want to get my bearings. And 340 is, the purpose is more like, I might want to implement or improve upon machine learning algorithms, and so I really need to understand how they work. So I guess, yeah, 340, how do ML models work? 330, how do I use ML models? That's basically the summary. Okay. So depending on your interests, you may want to take this course, you may want to take that course, you may want to take both courses. Personally, I think taking both courses is great. And in the survey that I'm going to have you fill out later today, I'm going to see how many of you have taken 340, which is a really useful number for me to know. But I know a bunch of people here have taken 340, and I expect this to not be a waste of time for you, even if you've taken 340. And for those who haven't, I'll be teaching 340 in term 2. So if you like this, you can sign up for, or attempt to sign up. I know there's always wait lists, but attempt to sign up for 340 with me in term 2. Any questions or comments about the stuff so far? Again, you can raise your hand in the participants tab, or you can post in the chat. What do you think of taking the two concurrently? I think that's fine. I don't see any particular issue with that. I think probably one or two people did that last term. Do we need to have experience with ML to take this course? No. So I'm expecting 0 machine learning experience. I'm just expecting some proficiency with programming, and we're going to be using Python, but that's it. No ML experience expected. Any other questions? I should also add that 340 has a heavier workload than 330. How proficient do you expect us to be with Python? So that's why there's an assignment due Tuesday that's just about Python rather than about machine learning, whose purpose is just to give you a sense of like the Python proficiency I'm expecting. So you'll basically answer that question for yourself by doing the first assignment. Okay, moving on. So registration, waitlist, and prerequisites. So again, there's info on this in the GitHub page. You can look at it later. But essentially, this year I did something different than I usually do. About 2 weeks ago, we just dumped the entire waitlist into the course, and I think it's unlikely that if you're on the wait list now, you'll get in. So we'll see. I think it's unlikely, though, to be honest. And if you are on the wait list and you're still trying to get in, you won't be able to do the stuff with Canvas, and that's fine. Just don't worry about it. And if you end up getting in, we'll deal with it later. A couple more questions in the chat. So do you expect some math in this course? No. So there's basically zero math in this. There's some addition and multiplication and some logarithms and maybe a sine and a cosine in one place. Nothing more than high school math. Does 330 overlap with 340? So what I've done for you is on the lecture schedule on the homepage, I have a versus 340 column in the schedule. So for every lecture, you can basically see how the two courses relate. So we're going to go into less depth on some things at the beginning. But then as we go forward, we're going to be going into more depth on a bunch of things. And then there's going to be a whole bunch of things that are just completely not in 340 at all. So take a look at the schedule to address that question. Any other questions? Okay. Course format. Oh, I just realized. I wonder if Zoom. Okay, great. Okay. Course format. So the lectures are Tuesday, Thursday at 11, as you know, because you're here. There'll also be watch parties at 8 p.m. on the day of the lecture. So if today is a lecture, that means today at 8 p.m. there will be a watch party, which means that a TA will play the recording of this lecture that we're doing right now. And you can watch it together with the TA and whoever else shows up, and you can ask questions and the TA will answer them in the chat while you watch. So you don't have to attend the watch parties. Obviously, you don't have to even attend lectures now if you prefer to watch the recordings. I'll try to make it worth your while to be here, but if you don't want to or you can't, that's fine. I know I surveyed you on time zones, and there's some people in time zones where 11 a.m. is just not going to work or other reasons. So that's understandable. And all the Zoom links for all these things, including the watch parties, are on Canvas under the Zoom tab, the same place you presumably went to get this link. So the optimistic plan is there'll be weekly assignments. I say optimistic because that necessitates me getting my act together to create an assignment every week. And if I succeed in doing so, they'll be due on Monday nights. So the idea is you can kind of get last week's material out of your system by Monday night so that on Tuesday we can start fresh with the next week's worth of material and just kind of separate things off week by week in our heads to kind of keep it clear. But that is contingent on me having my act together, so we'll see how it goes. The first assignment is due this coming Tuesday, September 14th, so that's very soon. Because it's not a long assignment. It shouldn't consume your whole weekend or anything like that. It's Tuesday, September 15th. Thank you. Oh, there you go. Okay, so there we go. That's what I wanted to do. Okay, Tuesday, September 15th. So 5 days from now. Yeah, it was Monday before, and then my TAs told me to change it to Tuesday because they said Monday was too obnoxious. So Tuesday, September 15th. At 11:59 p.m. and it's not about machine learning, it's just about Python, and just to see, to give you a sense of whether you are prepared to take this course. That's the purpose of assignment 1. If you go to this link, then you should be able to see your own personal repository for homework 1, and you should be able to get started right away. So take a look out for that, and you can start working on it right after this lecture if you want. And there's detailed instructions on how to install, how to submit, all this kind of stuff. But please use Piazza liberally, especially at the beginning, to help you troubleshoot any kinds of issues as well. Yeah, so Alan asked about office hours, and I do have office hours. Someone answered that. So going to this course calendar, which is linked to from here, the calendar, you can see the lecture, the watch party. Oh, so I should say there's no Thursday tutorial today. The Thursday tutorial will start next week because the TA wasn't available. Friday tutorials start tomorrow. And then you can see office hours. So yeah, I have 2 half-an-hour office hours, one in the evening and one in the morning. Again, just keeping in mind the time zone situation, trying to make myself available to as many people as possible. And then there's also TA office hours. So you can see one Monday evening and Wednesday evening. And I think, I forget, we might be adding one more. So that's the office hour situation. When would we expect the recordings to be posted by? So in theory, immediately after the class ends. I have heard from other instructors that sometimes there's a problem with Zoom that they don't actually get the recording until 6 hours later or something like that. So I'll just be limited by, after I'm done, Zoom is supposed to send me an automatic email saying, hey, here's your recording. And as soon as I get that, I'm going to post it. It should be right away. Will tutorials record attendance? No, they're completely optional. They're basically just more office hours. You can just think of them as more office hours. That's really what they are. How many hours are assignments expected to take? I don't know, 6 hours, maybe. It will vary massively from person to person. But yeah, I would say this course generally last term was perceived to be not super heavy in terms of workload. Next question, for those on the waiting list. Yeah, so I already posted about this on Piazza. You can take a look, but no, I'm not going to take someone off the wait list every time someone drops, because right now we're very overbooked, and I would need to get kind of below the 0 mark to let people in, so take a look at Piazza for more information on that. Yeah, you don't have to be registered for a tutorial. It's fine. You don't have to be officially registered. You can just show up. Where do we find the instructions for homework 1? So I posted the link up above in the chat. I can post it again here. So if you go to this link, you should hopefully be able to see your kind of personalized homework repository. And then in terms of instructions, homework submission instructions is kind of the main thing you want to look at, which is also linked to. What is the purpose of the tutorial session? So for now, they're basically just the same thing as office hours. We might have a more formal program, if you will, in the tutorials down the line, but for now, they're just office hours that happen to be in the official SSC calendar. How many people are we supposed to have for the assignment group? You'll do assignment 1 on your own. You may be able to work with partners in the future. I'm not sure yet, but I will let you know. But if so, it'll just be groups of 2. It won't be anything larger than that. There's some technical obstacles that are new for me to deal with this year. So I can't promise you'll be able to work with partners for assignment 2 onward, but I am working on that. Yeah, so that's this. Weekly tutorials will be in office hour format and are completely optional. You do not need to be registered. You can attend whatever tutorials you want. There's a midterm and a final. I'll have to think more about the format for the midterm and the final. Last term when we went online, the final was real time, meaning it was in the 2.5 hour window where the final was supposed to happen. And that actually worked reasonably well. So I'll need to think a little bit more about this. And I can have an answer for you before the drop date, but I need to think a little bit more about having the midterm kind of like a 24-hour take home versus actually doing it in class. So the tutorials in this course are basically just office hours. For the moment, yes. That may change, but for the moment, that's the plan. Okay, so the course calendar we already looked at. I'll just go to it again briefly. This has all the things. Course structure. So in terms of like the content structure, for the first half of the course, we'll basically be focusing on the fundamentals of supervised learning on tabular data. If that doesn't mean anything to you right now, that's fine. That will mean something to you soon. But it's kind of like we'll be working on the most vanilla standard case and just doing a complete thorough treatment of it. And we'll look at a different data set each week for the first half of the course. Then in the second half of the course, we'll kind of switch gears to common special cases. So what if you have time series data? What if you have language in your data? All that kind of stuff. And so we'll kind of dig into those special cases. Standard paradigm. Okay. And then for the last few classes, we'll talk about communication and ethics. And again, you can take a look at the tentative plan all here. So I've kind of mapped out the whole term more or less. By the way, the notes you see here, so if you go and look at, I don't know, lecture 16, there is something there, but it's from last term. So I can tell you lecture 16 will be similar to what you're seeing here, but I'm still going to be working on it right up until the class itself. So you can look ahead to get a general idea, but don't be mad at me if I make significant changes. Basically what you see in class is the final version, and I might be making changes up until then. I just thought you might like to have the versions from last term up there. Okay, next thing. So code of conduct. I have some stuff about that in the course documents that you can read about. But we'll be interacting over Zoom and we'll be interacting over Piazza. Those are basically the main places we're going to be interacting. And I just want to keep it all respectful. It's hard when we're online. We can misinterpret things easier. Many of us are just by ourselves at home. We can feel isolated easier. So please be sensitive of that and be nice. That's part of what I expect from you as someone involved in this course. So please also read this document about asking for help. I always cringe when a student posts on Piazza, like, I stayed up all night trying to fix this, and we're here to help you. So please ask for help when you need it. Any questions or comments? Okay. Grades. So you can see the grades on the course website. You can see the policy on challenging grades. I generally get a little grumpy around this subject. I think many instructors don't really like the whole grading aspect of our job, but I'll keep it professional, and please take a look at this policy for how I kind of expect you to conduct yourselves around grades and challenging grades. The course technology stack. So we'll be using Python and Git and GitHub for this course. And so there's instruction on installing Python and Git. And then there's kind of your Python environment that you need to set up. So one of your TAs, Chen, set up some files for you to kind of automatically set up your environment so that it'll install all the Python packages you need at the beginning of the course, and then we don't need to, oh, the Python link is broken. Sorry. Oh, I see, I merged it with resources. Okay. Yeah. Okay. Yeah, thanks. The setup is the one I was looking for. So there's instructions for setting up your Python environment. I guess we just don't need this because the link is right there. And yeah, if you run into trouble, again, post on Piazza. We really want to make sure you have everything installed and set up in the next couple of days, and you have that assignment due in 5.5 days. Python 3.7.3 should be fine, yeah. We'll be using Keras, PyTorch, or some other frameworks. So those are deep learning frameworks. We have one lecture on deep learning in the course, which is the computer vision lecture, and I have a little bit of Keras code in here, but you won't really be using Keras or PyTorch as part of this course. We'll just be kind of talking about it and not going into it too much. Okay, someone posted on Windows, the setup can be a bit problematic, but Piazza has a post, so take a look at Piazza if you're having problems. Also, some of the things I saw people were having trouble with on Windows, like XGBoost, just ask us. Some of them are super necessary, like pandas, and some of them are not that necessary, like XGBoost, and if you can't install that one thing, well, no big deal. So keep in touch with us on Piazza and office hours about that. Next thing, so lecture and homework format. So this thing you're looking at right now is a Jupyter notebook. As you can see, it's 01_intro.ipynb. So ipynb is the file extension for Jupyter notebooks. Confusingly, Jupyter notebook is both the type of file, like ipynb file, and is also the application, sort of like there's a Word document, and that is the file type, and Microsoft Word, that is the application that opens it, and the same thing here. There's Jupyter Notebook, the type of file, and Jupyter Notebook, the application. However, Jupyter Notebook, the application, is the old version, and people have switched over to Jupyter Lab, which is the new application. So what you're seeing here that I'm using is Jupyter Lab, and it has a bunch of fancy stuff. It's super nice. So as you can see, I have a bunch of things open. There's all kinds of good stuff you can do. So we recently, like a day or two ago, changed the install setup thingy to include Jupyter Lab instead of Jupyter Notebook. And it would be better if you were all using Jupyter Lab so that we're all kind of standardized on the same thing. So the way you open a file like this in the terminal is Jupyter space lab space name of the file .ipynb, as opposed to Jupyter Notebook, which was the old way. So I suggest you use Jupyter Lab and as the application, and then going back to the file type, Jupyter Notebook files contain all kinds of things. So you've seen they include text. They can also include equations with LaTeX, and they include code and all kinds of stuff. So there's two ways you can interact with one of these files. One is when it's statically rendered on GitHub. Like this here is a static rendering of the Jupyter Notebook on GitHub just for looking at it. I cannot run any of this code. GitHub in the browser is just giving me a way to take a kind of quick read-only glance at the file. And as you can see, it's just open in a regular tab in my Chrome, as opposed to actually opening the file with the Jupyter Lab application. And now you can see I'm not in a regular tab in Chrome. I'm in my Jupyter Lab tab in Chrome. And this, I have the whole Jupyter Lab thing, which is a web application running. And now the notebook is actually alive. So I can actually, let me first Where did it go? No. Yeah. Okay, so I can run the code. So this is Python code 1 + 1. I run it, I get 2. I can make a list called X with 1, 2, 3. I can set the first element to 999. I can print out X. So it's just executing Python code. And it's super nice. There's so much you can do with Jupyter Notebooks, as we'll be seeing next class on Tuesday, which I think you'll see the Jupyter Notebooks really shine when we talk about decision trees, which is kind of our first real machine learning lecture. And so we'll be using this file format for all the lectures and all the homework assignments. So it's something worth familiarizing yourself with. Just a quick heads up that by default, Jupyter prints out the value of the last line of code. So I don't actually need to do print X. I can just do X. And if it's not going to print out, if I do, 5, it's not going to print out X. It only prints out the last line. Right. Okay. Any questions or comments about any of this? Again, you can raise your hand in the participants box, or you can post in the chat. Is the Jupyter setup also in the instructions? Yeah, so the instructions recommend installing Anaconda, which will come bundled with Jupyter Lab. And then, the short answer is yes. Okay, let me just see where we are time-wise. Okay, got it. Can the Piazza post about waiting lists be seen by people in the waiting list? Yes, anyone with a UBC email address, as far as I know, can join any Piazza for any UBC course, so it's very open. Are we going to do any competition or project on Kaggle? Potentially, to be determined. I would like to, but it's just a matter of getting it all set up and whether I'll have the time to do that. So we might. The last couple of assignments are not exactly a project, but you will do kind of your own end-to-end analysis and then write a little blog post about it. So it kind of has a project-y flavor towards the end of the course. Okay, lecture style. So there's going to be lots of live coding. Today it's all text, but normally it's going to be mostly code and looking at output and figures and results in Jupyter. All the materials will be posted, all the recordings will be posted, and I already talked about the notes being available, so don't need to talk about that again. Next thing about me, so I did my PhD in machine learning, so this is my background. I've been teaching at UBC since I finished my PhD in this teaching faculty role, so haven't been doing research since then. I do a bit of consulting though, and part of the group that created the Master of Data Science program at UBC. I'm one of the co-directors of the MDS program. And this course is very in the MDS spirit. So they're kind of a similar flavor of being very applied machine learning. I taught 340 several times. I designed 330 this course. This is the second time offering it. I'll be teaching 340 again next term, as I mentioned. And finally, please call me Mike. I prefer Mike to Dr. Gelbart or any of those kinds of things. I don't think PhD professor people somehow deserve to have a special name compared to everyone else in the world. So just prefer to be called Mike. Okay, we're running over time, which is no problem, but let me reorder things a bit. So we'll take a break very soon in case if you're hitting the end of your attention span here. We'll take a break every class. Just one thing I want to do before the break is I'd love for everyone to fill out these 2 surveys. I'm going to post the link in the chat in a minute, but let me just say what they are. The first survey is just to tell me who you are. What's your degree in? have you taken 340, that kind of thing. It's super valuable for me to know who the audience is. So that's anonymous, and I really want you to fill out both surveys. The second, so I'll just show you. So this is the first survey. And just don't fill it out yet because I just want to introduce the other survey, but there's the link. And the second survey just asks if you like cilantro and asks you 2 questions before that. How much meat do you eat, and what percentage grade do you expect to get in the course? And the reason for the second survey is that, as I mentioned, we'll analyze a different data set every week in this course. And next week, we're going to analyze this cilantro data set generated by all of you. So you're all going to fill out the survey today. Over the weekend, I'll download it and get it loaded up into Python. And then next week is going to be all about this data set. In particular, can we predict if someone likes cilantro based on these 2 pieces of information about them? How much meat do they eat? And what grade do they expect to get in this course? We might not find any kind of relationship between these things, or I don't know, maybe. Well, we'll see. We'll see. But this is the first time I'm doing this. I think it'll be a lot of fun to analyze a data set created by you, but you actually have to help me create the data set for this to work. I'll be making this data set public because I'll be posting it on the course website, which is public, but I'm assuming there's no privacy issues here because you're literally just entering in these 3 pieces of information. A number from 0 to 100, another number from 0 to 100, and yes, no. So please click on these links in the chat and fill out these surveys now, and then press the yes in your participants box when you're done. And then we'll take a 5-minute break after that. So once I see that most people have pressed yes, then I'll start the timer for the 5-minute break. But if you're done early, you can go ahead and start taking a break, and you'll have a bit more than 5 minutes. So again, please fill out these 2 surveys. I posted the links in the chat. And then press yes in the participants tab when you're done. Thank you. So about Python. Some of you will have never used Python before in your life. Some of you will have been using Python for years. I hope that the Python we need to use for this course is not incredibly advanced, but there's some packages we rely on a lot, especially pandas, probably more than anything else. Pandas and scikit-learn. But scikit-learn I'll be teaching you. So I guess pandas is kind of the main thing, pandas and NumPy, and that's why assignment 1 focuses on those. So yeah, we're not going to teach these in this course, but there are resources. And so let me just show you these resources. So first of all, last year I had a lecture on Python in this course, but I cut it out to save time. And so here's the notes from that, which you can access on this resources page on the website. Also, last year I taught DSCI 511 in the Master of Data Science program, which is kind of like Intro Python. And all my materials for that are posted. So there's videos on YouTube and more Jupyter notebooks that you can look at. So these are kind of Python resources made by me, but then there's just lots of other things you can look at to learn Python. So take a look at that. Right. So yes, and I know there's going to be installation issues, and we're going to be there at Piazza to help you out. Another question. You mentioned you'll be updating the lecture files. Will you be doing the same for assignments? Well, when you have your personal assignment repository, like your CWL username _ homework 1, like that's it. I'm not planning to make more changes to that. So yeah, once you have your personal repository in GitHub for the assignment, I mean, there might be a mistake and I might have to correct it, but I'm not planning on making changes after I ship them out to you. Where can I find the Python reference material? So it's right here, following this link. I'll paste it in the chat, but also it can be accessed from the course website under other course documents. Wherever it is, one of these things, resources. Yeah, textbooks and online resources. Okay. Okie dokie. So we have about 20 minutes left. Okay, so yeah, for people posting about like install issues and stuff, please post on Piazza, and we and the TAs will help you with that offline. Sounds like you may not have activated your environment or something like that. Okay, so I'm just going to introduce the cities data set. I kind of decided over the summer that I don't love this data set, and so that's why I decided to do the cilantro thing, and also I think it'll be fun to use our own data that we created. But just for today, because I don't have time to parse out the whole cilantro thing in real time, I'll just show this cities data set very briefly only for today. So just to kind of get us into it. So I have a data set of cities in the US from the 2012 election, and they're colored by the vote. I don't know if it was like the more popular vote from that city in the election or something like that. And so this is the plot of it. You can see it kind of looks like the US. There's Republican voting and Democrat voting. And as you'll be doing on assignment 1, you'll be doing a lot of pd.read CSV. So I'm reading a CSV from data/cities USA. If you go to the course website, all the lectures are in this lectures directory here. And in the lectures directory, there's a data directory. So with respect to where we are now, the intro lecture, we're just going into data and grabbing the cities data set. So that's how that's being found. So we're loading this in, and we basically have a bunch of rows of data, and each one has the longitude of the city, the latitude of the city, and the vote, blue or red. So this is the data type that we're going to be working with for the first half of the course before we get to special cases. Is going to be some kind of table with rows and columns, and that's why we rely on pandas so much. Let me scroll up to the top for a minute. So here I imported pandas as PD. So pandas is this Python library that is all about data tables, basically, and so PD is referring to pandas. Let me scroll back. Yeah, that's why we use pandas so much, is because we're going to be working with tabular data a lot. And so here's what the data set looks like. It has 400 rows, as you can see, but it's only showing me the first 5 and the last 5. That's just the pandas Jupyter default when you print out a data frame. So this pandas object is called the pandas data frame. And we have 400 rows. Each row is a city, so we have 400 cities. Each city has 3 attributes about it: the longitude, the latitude, and the vote. And you can imagine the cilantro thing is going to look a lot like this next week. We're going to have maybe 100-something rows because there's 100-something of you that filled out the survey. And we're going to have a meet column and a grade column and a yes or no for cilantro column. And so I kind of modeled that after this because it's really nice to have a data set with 2 basically input columns, which are called features, because then we can make these kinds of nice visualizations, which is good for the beginning of the course when we're just getting started. So the thing we're going to be focusing on for now is called supervised learning. Supervised learning is the notion that you have some features or inputs, which we're going to call X, and some outputs or targets, which we're going to call Y. And Y is the thing you would like to predict, and X is the information you're going to use to predict that thing. And so we're going to try to predict if a person likes cilantro just based on their meat consumption and what grade they expect to get in this course. Or here, can we predict if a city is going to vote red or blue just based on its location, longitude and latitude, those 2 attributes. And so the whole way supervised learning works is that you start with some data set where you actually already know the right answer. So I already know, you already told me if you like cilantro or not, or I already have what the vote was. But can I learn from that? Can I build a model so that given some new values of X, so some new person, they tell me their meat consumption and their expected grade in the course, can I use that to predict whether they like cilantro because I've already done some stuff with the data set we collected before. Or here, if you gave me a new city and you said it was right over here where my mouse is, what do I think it's going to vote based on the data set that I have? So that's the general supervised learning paradigm. You have inputs. You could have multiple inputs. Right now, we're just talking about 2 inputs because that makes it nice for visualization, but we'll do a lot more than 2 in general. You have all these inputs, and then this output that you're trying to predict, which we call y. And then you have a bunch of rows, which are called examples. And it's an example of what we're trying to do. Input, input, output. Another example, input, input, output. So if 100 of you filled out the survey, we now have 100 examples of this relationship between meat and expected grade versus cilantro. And so that's why they're called examples. Any questions or comments? I do see a question in the chat. Ideally, should we be following and trying to code along during lectures? So yeah, that's an interesting question. A lot of people do that in in-person lectures, and they can kind of glance with their eyes between their laptop and the projector screen. But here, if you only have one monitor, it might be hard. If you have 2 monitors, maybe you could be following, or a huge monitor, maybe it'd be easier. But if you don't have enough real estate on your monitor, I feel like it might drive you a bit crazy to be constantly switching between my screen and your screen. And I suspect my screen would be the better bet if you had to make that decision. So it's awesome if you can code and follow along, but you completely don't have to. Whatever works for you is fine. You can also do it after the class, you know, boot it up and do it yourself. So whatever works for you. Yeah, I agree. I think it'd be distracting. But yeah, whatever you want to do is totally fine. Okay, so that's the supervised learning paradigm, which is, again, the thing we're going to be focusing on most in this course. And this kind of tabular data where you have some columns of inputs and a column of outputs, tabular meaning it's like a table or a spreadsheet, essentially. That's what we're going to be focusing on. The first half of the course is like the simplest case. Yeah. So someone asked about alpha, and someone already answered it in the chat. But yeah, feel free to ask questions if you don't understand any of the code. And I'll also try to make it clear if I expect you to be following along with the code or not. And I actually have the ability to minimize the code, but keep showing the output, which is a really nice thing in Jupyter Labs. So I may minimize the code sometimes if I don't want you to get distracted by it. What was index call equals 0? So you'll see that on assignment 1. Yeah, I'll leave that for now, but it's not super critical for our purposes at the moment. Okay, so what are x and y here? So x are, again, the inputs, which are the long and lat columns, and y is the output of the thing we're trying to predict. And so I basically just split this data frame into the input part, which is like n-1 columns, and the output part, which is the thing we're trying to predict. So yeah. Okay, so the reason why we typically use a capital X for X and a small y for Y is kind of like some conventions from linear algebra where people use capital letters for a matrix and the small letters for a vector, which if that meant nothing to you is completely fine, but basically we tend to use capital X because there's multiple columns. You could have multiple inputs, and a small y because there's just one column. There's only one output per example that we're trying to predict. So there's a bunch of kind of pandas and NumPy syntax that's useful. So we can look at the shape. X is 400 by 2, meaning with 400 rows and 2 columns. It's 2-dimensional because the table. Y has 400 rows and only the 1 column, and it's 1-dimensional. Okay, so one thing I want to talk about is classification versus regression. If you are a statistician, this will be confusing, so pay extra attention. In machine learning, here's how we use these words. First, we classify variables as, are they number variables, quantitative numeric variables, or are they category variables? And then we say, let's look at the thing we're trying to predict. If the thing we're trying to predict is a category, red or blue, or the I like cilantro versus I don't like cilantro, if the thing we're trying to predict is a category, we call that classification. if the thing we're trying to predict is a number, like in this diagram here, you're trying to predict the weight of something, and it could be any number, then we would call that regression. Statisticians use the word regression to refer to both of these cases, which can be extremely confusing. So please pay attention to the definitions that we'll be using in the machine learning world. So we'll be doing classification for, I think, the first 3-ish weeks of the course, and then we'll get into regression around week 4 or 5. And there's most of what we're going to learn is going to carry over, but there's just like a little bit of specialization between the two that we'll need to cover. And so that's why I'm doing it that way. So all this stuff, classification and regression, both fall under supervised learning because they're still both, you have some inputs and you want to predict the output. There is also something called unsupervised learning, and we'll just, briefly touch on that in the second half of the course, but not much. Okay, so I think we talked about a lot of this already in machine learning. We typically work with tabular data. Rows are called examples, columns are features, and then you have this target column, which is the thing you're trying to predict. That's Y. There's this document here that I made for the MDS program that basically covers different terminology. I call it the Statistics Machine Learning Dictionary, and because we have just such different terminology for the exact same thing, then you can see regression is right here at the top. But it turns out the same terms are used completely differently over and over again. It's just extremely confusing. So if you're interested or bored or anything, you can check out this document. But yeah, for the most important thing for us is that the rows can be called examples or samples or records or instances. I don't need this. I don't need this. Okay. So I'll be calling them examples most of the time, the rows. The columns I'll be calling features most of the time. Those are the input columns, I should say. And the output, I'll be calling targets most of the time. But again, statisticians have their completely own words for this, response and covariates and predictors and all these things, so keep in mind. And then training and learning and fitting, I'll use kind of interchangeably as well, and you'll see that in a second. Any questions or comments? Okay. Okay, DummyClassifier. So DummyClassifier is our first machine learning model or algorithm or whatever you want to call it. So it's our first classifier. So that's exciting. It is not very smart, hence the name, I guess. But it is going to do something and is going to introduce us to the pattern of syntax that we'll be using over and over and over again this course. And this will be the last thing we'll talk about today because we only have 7 minutes left. So almost everything we'll do in this course will be done using an open source Python library called scikit-learn. This is the most popular Python machine learning library. Maybe it's just the most popular machine learning library, period, actually, given the popularity of Python. I'm not sure, but incredibly popular machine learning library. And it's open source, which is really great because sometimes I just find myself wondering about something and I just go in and look at the code and I say, oh, how does this work? Well, I just open up the code and take a look, and that can be really nice. So yeah, really awesome open source effort. That being said, scikit-learn is not infallible. I have found a bug in it. It is made by humans. But it's pretty great. Okay, so there's a standard paradigm called fit and predict that we'll just be using over and over again that I'll kind of introduce today, but we'll really hammer that home next class on Tuesday. And so we're going to start with DummyClassifier in the course, but also I kind of want you to get into the habit of every time you approach a classification problem, start with DummyClassifier. And the reason for that will become clear in a second. But it's kind of the first thing we're going to talk about, but also the first thing I want you to do every time you approach a classification problem. So here I am importing it. Again, for those of you who are new to Python, the syntax will be new, but basically sklearn is scikit-learn, and I'm grabbing this dummy classifier so that now I can actually use dummy classifier. And one would have to have scikit-learn installed for this to work, but that's part of the installation instruction, so you will hopefully have it installed. So what I'm doing here, let me actually split this up even more just to really go line by line. So the first thing I'm doing, I don't know, am I still going to get a warning? Oh, I don't get a warning anymore. Great. Okay, so the first thing I'm going to do is instantiate a dummy classifier. So DC is now going to be a Python object of type dummy classifier. So scikit-learn is object-oriented in the way it's written. So I have this Python object DC that is now a dummy classifier. And I made a new dummy classifier with this syntax, dummy classifier open close. And here you could put all kinds of options. And we'll be putting lots of options and lots of parentheses in the coming weeks. So we'll be seeing plenty of that. But right now, I'll just use all the defaults. That reminds me, yeah, so if you are in Jupyter and you open a parenthesis for some sort of function and you do Shift-Tab on your keyboard, then it automatically pulls up the documentation, which is super cool because now I can see what the arguments could have been. I could have given it a strategy. I could have given it a random state. I can read about all the parameters. So this is basically the same stuff as if I just Googled dummy classifier and I could get to the full documentation. And I'm sure you'll be doing a lot of looking at the documentation. But this Shift-Tab thing is just super slick way of seeing it right there without even having to go anywhere. So that's really nice. Okay, so here's the kind of famous scikit-learn thing that you're going to be doing over and over and over again. You're going to be calling fit, so that the classifier object dot fit x and y, and that's going to do the magic of what we call training or learning or fitting or whatever you're going to call it. This is going to do the machine learning on this data set. So now, after you're done with fit, yeah, oh, that's why I had this thing over here before, just because I didn't want to get this warning later on. Okay, now now DC has been enlightened, and you can now do stuff with DC, such as make predictions for, in this case, new cities. So when you call fit and you give it the data, you give it the X and the Y because it needs to learn from seeing the right answer. That's how all this supervised learning is going to work. It's going to learn from seeing the inputs and outputs, and we'll be doing a lot more of this next week. But the dot fit is kind of the first thing you're going to do. The next thing I could do is I could ask it for a score. So well, maybe even before that, I should say, let's say, okay, so I can give it some coordinates, 0, 0. I don't know where 0, 0 is in the world in terms of lat long. Or if it even exists. It must exist. But anyways, I can take some new x's, some new lat and long, in this case 0, 0, and now, hey, DC can make a prediction. It's going to say, oh, you want to know about 0, 0? Well, hey, that's going to predict blue. Oh, 0, 0 is called Null Island. Cool. To answer the question about training and testing, that's going to come in lecture 3, so a week from today. So now dummy classifier can already make predictions. And so what you can do is you can ask it for its score, which says, given, again, that same data set of cities that we looked at up here, given, sorry for the scrolling, given this data set, how well does dummy classifier do using its learning when asked to predict on this X? So let's basically saying, let me predict on all the X's and compare to the Y's, which we know the right answers, and let's see how many times we get the answer right. That's what dot score does, and it says 58% of the time I'm getting the answer right, which is actually not very impressive. So I try to never go over time. So there's a few more things I wanted to talk about. I'll just say very quickly that what dummy classifier is doing is it's actually just picking the most popular output. So if you look at Y, there's actually 234 blues and 166 reds. And so what dummy classifier is doing, if you predict on all the X's, it's actually just predicting blue everywhere. That's why it's dummy. It's just kind of silly. All it's doing, the whole fancy machine learning is doing is just saying, what is the most common? Oh, blue is the most common? Okay, I'm going to predict blue no matter what input you give me. I'm not even going to look at the input you give me, which is a very silly not very effective machine learning algorithm. So that's kind of our baseline. We'll be doing much more interesting things in the coming weeks. And I had an activity in case we had time. We don't have time. I'll post this on Piazza, and we can follow up with that later if you're interested. But I want to end on time, so nice to see all of you, and we can end here. See you all on Tuesday.